A type system is a way of rejecting some expressions before we even get to interp so that we reject all the bad programs. But as we saw, we can't reject only bad programs. The way out is to also reject a few good programs, hopefully ones we don't care about. For example, suppose in our example before where we ran afoul of the halting problem, suppose that the question here is this number prime? Now we know that primality testing is arbitrarily complicated, can take arbitrarily long, so we don't want to run it to find the answer. We're just going to say that this is disallowed. We're going to reject this program because the two branches, this branch, the second branch, might return the identity function and we need a number. Okay? So a type system is going to make this compromise. It's going to say, I'm just going to look at the branches of the if, not try to predict what the test does, and only if it's always okay, whatever the test does, then I'll accept the program, otherwise I throw it out. And in fact, we're probably happy to throw out this program. No one would want to write, if it's a prime number, then return 1, otherwise return the identity function, at least not as the argument to a plus 1. So that's our overall strategy. And the way that we avoid evaluating things, but still classify them in a useful way, is to give a type of each expression. So we're going to give 1 the type number and lambda a function type. And then because a number type and a function type are not the same, then we're going to reject this if. We'll also make sure that the test here has a Boolean type, something like that. So types are a static classification. We have to make type decisions without running the program, but then we have to set up our type system so that we can make accurate predictions about what will happen when we do eventually run the program, so that we can make sure we reject all the bad programs. And you're familiar with type systems, so you know roughly how this goes, right? The expression 1 has the type number, and the expression true has the type Boolean. Now num and bool here, these are just sort of symbols. They're just classifications that we have syntactically assigned to these two different expressions. If we have a plus 1, 2, then we are going to consider that the 1, that syntactically has type number, and the 2, that also has type number. And so in that situation where we have two arguments to plus that both have a number, we will say that the plus expression has type number. On the other hand, if we have plus 1 and then false here, 1 is type number, false is type Boolean, and in this case we're not going to give a type to the plus expression. We're going to say it doesn't have a type. We don't give it the type no type, we say it doesn't have a type. And since it doesn't have a type, then we're going to call it ill-formed. That is, the programs, the expressions that have a type, those are well-formed. The ones that don't have a type, those are ill-formed. And as long as we only give a type to programs that will produce a value instead of raising an error, then we make sure that we've ruled out all the ones that will give an error.